Good morning. Today we will learn a very new concept and very interesting concept that is of the new era of the world, that is nanotechnology and nanoscience. So let's see what is the canvas of nano. What is meaning of nano, nanoparticles, nanomaterials. The canvas of nano covers it. So, what are the nanoparticles? Nanoparticles are the particles of the materials obtained from joining of atoms or molecules that ranges from the sizes 1 nanometer to 100 nanometer. So, below 100 nanometer, the particles called as the nanoparticles, and below 10 nanometer, they are called as the quantum dots. So, how they are formed? They are formed by the joining of the atoms. So, atoms when release electrons, they forms the ions. So, whenever the ions are formed in the solutions, they are reduced by the reducing agents or precipitating agents to the electrons. So the ions get reduced by the electrons, by these materials, that substances, and joining of the atoms forms the nanoparticles. So by the atom reduction method, nanoparticles get formed. So there are two types of the synthetic methods, top down and bottom up. Top down methods of the synthesis of nanoparticles and nanomaterials consist physical methods, which also based on the vapor deposition. Bottom up approach of the synthesis are dependent on the chemical and biogenic synthesis methods. In that, famous synthesis are the chemical synthesis, and very well today's known methods are the biogenic methods. In plant extract, synthesis is performed. So after synthesis, the nanoparticles get characterized and they have the applications. But for the synthesis, what instruments are to be used? Stirrers, autoclave, sonicator, centrifuge machine, muffle furnace, oven. These are the basic requirements in the lab to form the nanoparticles. So how they are characterized? After synthesis, nanoparticles or nanomaterials, they are characterized using spectrometric techniques like UV visible spectroscopy for their formation studies, XRD to detect the presence of the planes and atoms, PL spectroscopy, fluorescence or photoluminescence spectroscopy, XPS, EDAX to study the elements present in the nanoparticles. Then microscopic analysis performed like scanning electron microscopy, transmission electron, atomic force, AFM to determine the morphologies and shape sizes of that materials. Analytical techniques like XRD, VSM, vibrating sample magnetometry, dynamic light scattering are used to study the nanoparticles in detail. So what are the application areas of these nanoparticles? There are different areas, but particular the main areas are the bioanalytical, biomedical, catalytic, sensing, photophysical and labeling detection methods used from the nanoparticles in this new world of the nanotechnology. So what are the types of that nanomaterials and nanoparticles? They are present in the nanometal forms. They are oxides, nanooxides, ceramics, nanocomposites, nanoconjugates, conjugates with the molecules by the metals. Then this gel form of the nanomaterials are present, diatomic forms are there and cluster forms. So here I have represented or I have kept here one type of the nanoparticle gel here. So look, in this vessel there is a gel of nanoparticle. So this is the important canvas of nano, you must know.